Hi, everybody. This is our first video lecture, picking it up where we left off in Chapter 8. So I hope you guys are doing well, and these video lectures, they come out clear, and they're easy to access and that sort of thing. I'm going to try to not go too fast, of course. Difficult when I don't have you guys, sitting there in front of me, but I'm going to do the best I can. I'm going to try to keep the videos short, relatively speaking. So say 12, 15 minutes at the most. I'll pause and maybe we come back and chat some more. Of course, feel free. Obviously, you guys are pretty familiar with this sort of thing. Pause it anytime you need to watch it again. And hopefully, we can have some good discussion when we meet live starting on Monday. I'm actually, since this is our first video, let me switch over here. I'll show you. I'm actually still, here I am. I'm still in my office this week. By the time you guys see this, they will have closed the whole campus. So I'll find some new place to broadcast from. That's for then. Okay, so we're here. Our next section is 8.8 on complex numbers. So the last thing we talked about was 8.6. We're skipping 8.7, going right to 8.8, the last section that's in the textbook, although we're also going to chat about 8.3, and you'll see videos for that too. Okay, so what is 8.8? It's complex numbers, maybe more familiar languages and imaginary numbers. We're going to see I appear pretty soon. Just super fast, just a tiny bit of context here. So oftentimes students see the name imaginary numbers, right? And that seems ripe for how could this possibly be useful in the real world? And that totally makes sense. The name really does not do justice to what we're about to see. Imaginary numbers, they came up with that name a couple hundred years ago and it stuck, but it lends to that sort of thing. So at the same time, think about other things. So it turns out if you go way back into history, the number zero, people really had a difficult time with the number zero for centuries. And it turns out the number zero is actually really, really helpful and very realistic and applicable. Then came negative numbers, and people really had a difficult time with negative numbers. How could you own -5 sheep? Right, that doesn't make sense, but maybe you think of it as a debt, obviously. And so negative numbers, they came around to be fully accepted. Then zero. How can I own 0 sheep? Right, I don't own 0. There's just none. But it does make sense. Same thing with imaginary numbers. The name really doesn't do it justice. Okay, anyway, let's get to it. These are highly applicable in the real world. Here's what it's all based around. The imaginary unit, we're going to say it's all about square roots of negatives. So we'll say the square root of -1. Now we're going to give it the name I. So I is a number. It's whatever the square root of -1 is. So that's not real, obviously. So we need this new idea of the imaginary unit. So we're not going to keep negatives under a square root anymore. We're going to use the number, if you will, I. So a couple of quick examples before we get into the harder ones. And I'm kind of showing you the first line of this already, just the way I've laid it out on the page. But okay, what if we were looking at the square root of -25? We'd think, hey, let's think of it as the square root of 25 times -1. Okay, break it down just like we've done with other things. And then we can take the square root of each one separately. I'm going to say, oh, well, the square root of 25 is 5. The square root of -1 is I. So I'm going to say the answer to square root -25 is 5i. I take the square root of 25 in the same way. Because it's negative, now I attach an I. They could get more difficult. I think I'm giving away the first line here again. If we had the square root of negative 48, hey, can we reduce this? Can I reduce 48? It turns out 48 is 16 times 3, so I've got my perfect square. Happens to be times 3, and it's negative, so let me attach a negative 1 as well. If I was to look at the square roots individually, well, square root 16, 4. I don't know about the 3. Let's skip to the negative 1. Square root of negative 1 is I. And then the square root 3 tags onto the end, just like reducing square roots that we've seen before. There just happens to be a negative in this one. Okay, so now that we're getting kind of familiar, let's develop some of the language. I'll just show you all this. We say a complex number is the combination of a real number and an imaginary number with I. So answers to everything in this section are going to take this form. A plus B times I. A will be a typical number. We'll say it's a real number, the real part. B, since it's multiplied by I, is the imaginary part. Okay, so every answer in this section will take this form, a number plus a number times I. That's how we're going to write it. Even the order matters. The real part comes first, the imaginary part comes second, and that gives you a hint why this thing has the name complex. Complex meaning there's more than one part. That's the complexity. And you're saying, okay, well, the things that we looked at before, just a moment ago, 5i, 4i, or square root 3, there was no real part. It was just the imaginary. Those would be examples of a purely imaginary number. If the real part is 0, or that it's not there, and you just have a number times I, then we say it's pure imaginary. Again, that was the case with 5i. That's pure imaginary. Okay. I think you guys get it. Let's move on to the examples that we're going to see. Start off with here. Okay, so the task is to simplify. Everything we do in this section is simplify. We'll answer in that standard form A plus BI. We're going to learn how to add, subtract, multiply, and divide with complex numbers. So let's start with adding. Part A, how about the complex number 2 plus 3i plus this other complex number, negative 6 plus 7i. They each have a real and an imaginary part. The parentheses kind of show that. Okay. Well, it turns out we're just going to combine these just like we would if it was something a lot more familiar. So we're going to say, well, you know what? Since we're adding these parentheses here on the second half, they don't really do much. Let's just get rid of those. And then let's combine the like terms, right? Combine the constants, combine the imaginary parts, combine the reals, combine the imaginaries. And there's our answer. 2 minus 6, 3i plus 7i, negative 4 plus 10i is our answer. Okay, so far so good. Let's try one. Again, I apologize if I'm moving too quickly. Trying not to do that. Let's move on to this. Five plus the square root of negative 36 minus 2 minus the square root of negative 4. Some of the questions you're going to be given, at first, they don't contain I. They have these square roots of negative numbers. So the first thing we're going to do is convert these to using the I. So we'd say, okay, I've kind of done that here. The square root of negative 36, I'm going to turn that into 6i. The square root of negative 4, well, that's 2i. And so if I'm adding, then I'm adding. If I'm subtracting, then I'm still subtracting. Everything else gets copied just the same. I just have that first step of rewriting them with the I. And then I proceed as normal. Here, since we're subtracting, our negative sign is going to distribute. And I end up with this line, minus 2 and plus 2i there. Then I combine my real parts, combine my imaginary parts, and my answer here is 3 plus 8i. Okay, hopefully so far so good. We've done addition, we've done subtraction. Let's see if we can multiply. And here something's gonna come out. As you can imagine, multiplying is gonna be a little bit more difficult. Let's see how it goes. 2i, I've got this pure imaginary number, multiplying with 5 minus 3i. Okay, how's this gonna work? Well, we're gonna distribute. And what's gonna happen? I'm trying to not reveal something over on this other side of the page. Okay, there we go. 10i minus 6i, and 6i squared, 2i times 3i. Okay, just like if it was x times x, x squared, I times I is I squared. And now think, well, how is this going to work? The goal, you said that we can write everything to be a real part plus an imaginary part times I, a plus bi. Here we have an I squared. What's up with that? So let's take a look at that kind of on the side here, and I've got my note. If I equals the square root of negative 1, if I square both sides, wouldn't I squared equal, and if I square there, negative 1? So it turns out I has this really interesting property, that if I square it, it cancels the square root, so I squared equals negative 1. I'm going to come back here and replace I squared with negative 1. 10i minus 6 times negative 1. And now that part that wasn't I squared now turns real. 10i plus 6. And they go, okay, great. I've got my real part. I've got my imaginary part. Looks good. Turns out we're not done. We don't have the answer yet. It has to be in the right order. We need to reverse these. The real part comes first, then the imaginary part comes second. That probably seems kind of too much, kind of over the top, really nitpicky, that this would not be the standard form, that you have to put the real. Then that's the way it is. The standard form is the real part first, the imaginary part second. That's how everything is gonna. We need to be really careful there, even at a last step, to make sure to switch them. The big lesson here is, of course, what to do with I squared, and we're gonna see more of that in the next examples. Okay, I've got one here. I'm just gonna show this to you guys and invite you to try it out. We'll start the next video by doing this one together. But I'm just gonna present it to you now. What if we had this complex times that, 5 minus 2i multiplying with negative 1 plus I, like so. I'm gonna end this video here. Take a minute or two, try this one out. When we start the next video, we're gonna do this one together. And I think we'll be able to finish off the section even in just the second video. So, okay, good luck. I'll see you in the next one.